This DBI's Brother Panther. I've got a database here I've been monitoring. I'm going to do a response time analysis for this database, and what I see here is for the last 8 hours, not much going on. I actually want to look at the entire week, so I'm going to look at the performance of this database for the week, and I've got a 1/4 second response time. 85% of that time is inside the database, and the database is a little bit more I/O bound than CPU bound. I'm going to click on that I/O pie slice, and Brother Panther just did the analysis to find the statements that are causing that database to be I/O bound. So right there, I've got about 2/3 of all the I/O in the database tied up in these 4 statements. I can pass those as a workload to the design advisor and apply DBI's advanced index benefit analysis methodology. So here's an I/O bound database, 2/3 of all the I/O in 4 statements. We're waiting for the answer here. Do-dee-doo-dee-doo-dee-doo. Oh, outstanding. And we can see we're going to get from 374,000 time rounds down to 116 for a 99% improvement. Here's the indexes that we have the opportunity to create, and we can see the benefit of each of these indexes. If we add this first index, we'll get 49% of that savings. If we add this second index, we get 46% of that savings. And if we add this third index, well, that's not a very big contributor to all that savings. So I take these first 2, that's the bulk of my savings, click on create. There they are in my editor. I'm ready to go. And just like that, in about a minute, I just took 2/3 of the I/O out of an I/O bound database. Isn't that easy? Yes, it is.
Yes, please. And this is Rajesh, and I am from the DB2 community and practicing LUW for quite some time, and starting from 8 onwards, and my journey is around 10 years in DB2. Though I have not participated in DB2 Got Talent, I have seen certain use cases and got it used to it. Today I'm going to talk about something on LOB, so large objects. So large objects, many people think that it's not my cup of cake or cup of tea to look into it. Why? Because it's always a vague area where people will think that why I should go for an LOB instead of I would go in for some other table which can be elaborated as well in separate columns. So a certain need which in recent applications where I have been working is a mobile platform where some JSON data has to be transferred, and along with pictures that has to be stored, has to be in LOB as an LOB column. So I'm here to talk about some LOB use cases, usage in applications, business and technical problem that drives me in how to speed up something on LOB object, and how are the environment guidelines or the DB2 guidelines for achieving it. So what and why an LOB? So LOB is a large object, say club or a blob, which gets stored into a database, a column for storing large objects. Say generally it holds still a 2 GB of data. Say a big elephant of 2 GB can be stored in. Though data is huge, you can store it outside. So data that gets stored in a column is a descriptor. So anything more than your X amount of data that gets stored in a column has to be separated out, because database cannot handle it within the boundary of the table space. So an LOB descriptor is the one that gets assigned to it, and each descriptor defines it which space that it's going to store, and whenever a request comes in from a query, it just picks it up and throw it out. typical is in a transaction and OLTP processing, we see a lot of this LOBs gets added out. And now going to the business technical problem. So I was supporting a customer in financial lending platform where some external SFDC sources has to be linked in, and some large objects of storing thumb impressions and some images of faces has to be stored in. While testing one of the data, what the developer came to me is that see, I'm getting a query that is which is fitting in, and the explain plan looks good for me, but one table record that is fitting in is not getting me result. So when I drill down into the problem, the underlying explain plan looks good and nothing was bad about it. So when we investigated about what needs to be done about it is that a club column was given a 10 MB, and a 10 MB of storage has to be outside of boundary, and the entire 10 MB was occupied for a separate single column. So where within nanoseconds, when other records are processing, this record only could not process because it has to fetch it from the disk, and it takes quite some time to load into the browser. So when I drill down onto the club, what best we can give it for the performance, I just figured out some database metrics which can give an insight of how the log can be handled. So database metrics in the sense you can have a snapshot taken and check the read writes out how a large object is behaving. And secondarily, the design considerations say a club cannot have a 10 MB column, which if it is required, yes, it is required. But when you can do something similar to say, I start with 1 MB and later on move in across whenever it is required. And the other ways of improving performance is how logs are logged. So there is an option of no logging in your lob objects to make sure that your lob is not logged always, and you can compact the lob objects and make sure that your table space is not file system cached, so that it becomes an advance to not to get into the cache and get it from the disk directly. The third option is an inline. So inlining is an important feature of LOB where when you get an average size of the column based on an inlining of length, say a function that gives you the information about it, get that information, average that, and see to it if it can fit into your LOB. So when you inline the LOB column, what happens is it fits into the buffer pool and make sure that the records gets processed within the buffer pool and gets it to the client easily. In my case, when I used inlining of LOB, I could see a performance processed by 10% and my turnaround time improved by 30%. I just giving an example of how to use the inlining admin. Yes, inline length is the table function I used, and I used it for getting in the average of it and make sure that that gets fitted into whatever my page size is. So my recommendation is whenever you do a large object, re-arc the table with the lob data, long lob data, so that the freeness of the space or the buffer gets fitted into wherever it is possible. And always go in for a 32K buffer pool if you're having a large object. That gives maximum size that DB2 allows, so that you can operate on how much ever the inlining can be done.
Well, Rajesh, I think you got ducked, and looks like just at the end there. I guess that was pretty good timing.